Hello everyone, my name is Ruxana, and today I'm going to explain my lab experiment number 5, that is dynamic routing protocol configuration for multi-subnet communication. The aim of this lab experiment is to design a network topology and configure dynamic routing using RIP and OSPF so that routers can automatically exchange routing information and find the most efficient path for data transmission. In this lab, we have worked with two major dynamic routing protocols, that is the RIP and OSPF. RIP or Routing Information Protocol is a distance vector protocol that uses hop count as its metric with a minimum of 15 hops allowed. RIP sends updates every 30 seconds using UDP port 520. It is very simple to configure but not suitable for large or complex networks. Talking about OSPF, it stands for Open Shortest Path First. It's a link state protocol. It uses Dijkstra algorithm to calculate the shortest path between networks and supports hierarchical design with areas, sends updates only when there are topology changes, and is highly scalable, making it ideal for large networks. So this is the topology diagram. As you can see, the topology diagram consists of three routers and three PCs connected to the router. Coming to the configuration command part, after designing the topology and assigning IP addresses, we configure the routers with both RIP and OSPF commands. For RIP, the configuration commands were router RIP version 2, network 192.168.20.0, network 172.160.16.10.4, no auto summary. So we are giving the IP address for router 1. When coming to OSPF, the commands include router OSPF 10, network 192.168.10.0.0.0.0.255, area 0, network 172.16.10.0.0.0.03, area 0. These commands ensure routers share routing information and dynamically update their routing table. To verify that the dynamically updation of the routing tables are done properly, we use these troubleshooting commands here we are using the commands such as show IP route, show IP protocols, and debug IP RIP or debug IP OSPF to check the configurations. The routing tables displayed learned routes from other routers and the other OSPF neighbors and database outputs confirmed proper communication between routers. Finally, we verified end-to-end connectivity by performing successful ping tests between PCs on different networks. Thus, we have configured dynamic routing using OSPF. The routers the routers were able to exchange information automatically, calculate optimal paths, and reroute traffic when links failed. Again, to summarize the procedure, we configure IP addressing on the host PCs, then configure router interfaces, then configure the router to install the static route in routing table, then we test and verify the configuration. These are the procedure we follow to build this configuration. This is the addressing table where we have the devices, that is three routers and three PCs, that is R1, R2, R3, and the PCs PC1, PC2, PC3. We have the interface, IP addresses, subnet mask, and default gateway for all the routers and PCs. This is the output screenshot, that is the configuration. Here we added the screenshot of the IP addresses, subnet masks, and default gateway, etc. So We have built the so thus have successfully configured dynamic routing and the information are automatically exchanged, calculate optimal paths and reroute traffic, etc. And that's all. Thank you.